stars, clusters, interstellar gas, dust, dark matter, and planets, which all are bound together by one gravitation.
Welcome. Welcome to Star Diamonds. Star Diamonds channel. Welcome to Star Diamonds TV channel. Welcome. I'm Big Mama LALA, and I'm here. We're going to do a commentary on the show, A Journey Beyond the Milky Way. A Journey Beyond the Milky Way. You will hear me speak and give some commentary in between uh, the video. Yeah, this is my first video here, one of my first videos on the Star Diamonds channel. Thank you for watching. Go ahead and subscribe so you don't miss out on any more Star Diamonds wonderful content and wonderful videos. Yeah, Star Diamonds free TV right here. And I will give my comments in between. You may hear some music or either a pause. That's so I won't be striked on YouTube. This is a fair use act for entertainment purposes. Like and subscribe. Thank you so much for watching.
Companion galaxies, which are objects orbiting around a larger galaxy due to the gravity of the latter. The second class is spiral galaxies, which are peculiar for the central bulge cocooned in a disk. And the third class is irregular galaxies, typically unsuited to either of the proposed categories. As a rule, they are chaotic formations with neither a clear nucleus nor spiral arms. Lenticular or exogalaxies, elliptical galaxies, and barred spiral galaxies like our own Milky Way fall into this category too.
I'm giving a thank you, and a shout out. Thank you and shout out to Cosmo. Thank you, shout out to Cosmo.
To 800,000 light years.
The
Just
Milky Way is
compare,
wonderful.
the diameter of the Milky Way is 30 kiloparsecs.
The Milky Way is
That
wonderful.
is 100,000 light years.
The Milky
The
Way is
largest
one
galaxy
galaxy.
known today is called IC 1101, and it boasts a diameter of over 6 million light years.
Now, ain't that something? The Milky Way is just one galaxy. The Milky Way is just one galaxy. That's wonderful. There's many galaxies.
Of the overall mass of a given galaxy. Alternatively, another galaxy may be completely devoid of it. But which of these objects can be defined as the nearest to us? Many would argue that it's the Andromeda galaxy that is the closest, which is located 2.52 million light years away. However, this is the closest object among the largest spiral galaxies. As for the closest galaxy, a hypothetical Canis Major dwarf galaxy should be named. This astronomical object belongs to the local group as well. The galaxy contains a comparatively high percentage of red giant stars and presumably a billion regular stars. It is classified as an irregular galaxy and is officially considered our nearest neighbor.
I am a star.
The galaxy is located
Big Mama LALA is a
25,000 light
star.
years away from the solar system,
a superstar.
and 42,000
That's why I named
light
this
years
channel
from the center
Star
of the Milky
Diamonds.
Way.
I'm a
This
diamond in the
object
rough
was discovered
also.
in November
I am a diamond in the
2003 by an
rough.
international team of astronomers.
Like and
In
subscribe
spite
to
of its
support
close
this channel.
location to the
Subscribe.
Earth,
Thank
the
you.
galaxy wasn't easy to spot because it is located beyond the plane of the Milky Way in the area with stellar, gas, and dust over density. Our second closest neighbor is the Sagittarius Dwarf Elliptical Galaxy, which used to be considered the first one as well. It is a satellite galaxy with a clearly defined elliptical structure with its orbit passing over the Milky Way. The object contains 4 globular stellar clusters, with the first of them discovered in 1994, which led to the discovery of the galaxy itself. Its diameter makes up about 10,000 light years. It is about 70,000 light years away from the Earth and 50,000 light years away from the core of the Milky Way. It is thanks to this galaxy that the Milky Way may have obtained its arm structure. This conclusion is based on numerical modeling. It was arrived at by researchers from the University of Pittsburgh. According to their version, the arms of our galaxy may have been obtained as a result of a collision with the Sagittarius dwarf elliptical galaxy. This object is currently in the process of merging with the Milky Way. It should be noted that it has passed through the plane of our galaxy several times. The last time took place about 150 million years ago, which agrees with the data received by the Gaia telescope. When speaking about our nearest neighbors,
My mama had a friend named Sister Gaia. We grew up with Sister Gaia in church. Sister Gaia. Yeah, that was my mama friend she met in church. We went to we grew up in the holiness church. Then we went to my mama ended up going to apostolic church and then the Pentecostal. But I'm back to the holiness church. Back to the video, back to a journey beyond the Milky Way with Big Mama LALA. Somebody trying to play tricks. It's a full moon. Yeah, we just had a full moon. April 10th. Full moon. Happy Easter. Full moon. That's why it's acting crazy. Hallelujah.
Dwarf galaxies and satellites of the Milky Way. The Large Magellanic Cloud is 163,000 light-years away from us. That is a distance almost 1.5 times bigger than our galaxy. The Large Magellanic Cloud finds itself in the area between the Dorado and Mensa constellations in the southern hemisphere, which is the reason why it is unlikely to be seen from most of Eurasia. The galaxy is approximately 10 times smaller than the Milky Way and contains approximately 30 billion stars. The mass of the Large Magellanic Cloud is about 300 times as small as that of our galaxy. However,
I love that movie Ultraviolet, and purple is also my favorite color. Yeah, lilac is Big Mama's favorite color. Purple, red used to be my first favorite color when I was a child, but now lilac or ultraviolet purple is just fine with me.
40 times that of the Sun. Hypothetically placed in the core of the solar system, it would reach as far as the orbit of Saturn with its edges. The Milky Way and the Large Magellanic Cloud are expected to collide in approximately 2.4 billion years' time. Its neighbor, a small Magellanic Cloud, should also be mentioned. It is a dwarf galaxy too, and is enveloped in neutral hydrogen. The small cloud is 60 kiloparsecs away from us. That is approximately 195,000 light-years. It is located in the Tucana constellation and has the appearance of a faint spot about 3 degrees in size. 1.5 billion stars are thought to be found in the small Magellanic Cloud. However, they are not visible from most of Eurasia either. According to the data published in September 2014, the Milky Way is likely to swallow up this object as well in 4 billion years' time. To date, the number of satellite galaxies in the Milky Way equals 18, but the number of large systems closest to us reaches 115. This is hardly the full list of these objects, because new dwarf systems are discovered now from time to time not far from the Milky Way. Pinpointing and exploring objects like that is a rather arduous task. However, the search for nearest galaxies remains one of the chief objectives in astronomy today. Their discovery might give us insights into new planets similar to the Earth, and might lead to the discovery of life forms in the nearest parts of the universe. The statement that there are boundaries to the universe is considered per se one of those great ideas which are able to dramatically change our world perception. Something similar took place back in 1543 when Nicholas Copernicus proved that the Earth wasn't located in the center of the cosmos. The following breakthrough took place in the 20th century when Edwin Hubble showed to the world that galaxies moved away from each other. This prompted the idea that the universe hasn't existed eternally and was formed as a result of a certain event, the Big Bang. Today, we are certain that the dimensions of the world we live in are much larger than we are capable of imagining. The search for the answer to the question about its boundaries is going to lead to yet another scientific breakthrough. At the moment, scientists are able to talk only of the boundaries within which the objects are visible. This area is also called the observable universe. That is its part which is the absolute past in relation to the observer. The cosmic horizon is the boundary of the observable universe. The objects on the horizon become infinitely redshifted, that is, they constantly move further away. The number of galaxies within the observable universe is estimated at upwards of 500 billion, with this number increasing on a regular basis as the research equipment becomes more advanced. But how big is the observable area of the universe today? The distance to the remotest observable object equals approximately 14 billion parsecs in all directions. Thus, the observable universe is a sphere with a diameter of about 93 billion light years and with the center inside the solar system. That is, it is centered on the observer. The area equals 350 quinvigintillion cubic meters. It should be mentioned that the light emitted by the furthermost observable objects has been traveling for 13.8 billion light years before reaching us. However, the distance to those objects has significantly grown due to the never ceasing expansion of the universe. This process is the result of there being matter and energy in space, filling space-time. While there is matter in space, there is gravitational force. Therefore, the universe either shrinks, affected by gravity, or expands, affected by dark matter. It is also worth noting that there isn't a single center for the universe's expansion, just like there isn't a space for the universe to expand into beyond its boundaries. This process takes place with the matter in space at any point, everywhere, and at all times. We do not physically perceive this, as the force holding our atoms and molecules together does not allow us to burst under the influence of the space expansion. This may be compared to a baking loaf of bread, with the raisins for galaxies and similar formations and the dough for the space matter. According to estimates, the distance to the furthermost observable objects today equals approximately 14 gigaparsecs, or 46 billion light years. The furthermost stellar system with respect to the Earth is a galaxy dubbed GNZ11. Its light has been traveling to us for about 13.4 billion years.
Subscribe. When you subscribe to Star Diamonds, you will see more TV shows. Yes, this is Big Mama LALA TV show where I will be giving commentary on different things about the galaxy and scientific things. Also, I will have other uh, TV shows about consciousness TV, other TV shows about books, reading books, or I might just read, books and with commentary, or I might just read the books. Different TV shows, all on Star Diamond's channel. Subscribe to Star Diamond's channel. Yes, this is one TV show, Big Mama Lala. Like I said, I will have other TV shows, consciousness TV shows for African Americans, also books for everybody, anyone watching, any race, books, poetic books, fiction, nonfiction books. Coming in the works also current events TV shows. Eventually in the future, I hope to do podcasts with special people, famous, well-known people. Also, um, lecture TV, parenting 101 for single parents. All my videos will be very informative and very inspiring for you. Big Mama LALA is out of this world. Yes, I'm the biggest star in the galaxies.
where it is depicted before the formation of the first stars. It is likely that the universe stretches infinitely beyond this barrier, and it is there that its hypothetical boundaries are to be found. The objects beyond this barrier are referred to in a number of ways: multiverse objects, parallel universe objects, to name but two. Science today is incapable of defining these bodies with any detail. However, assuming that the universe carries on expanding,
It looked like a sperm, didn't it? It looked like a big sperm or either a big egg. The universe is somewhat similar to the body, the inner side of the human bodies. The inner being of the human bodies is the universe. Our ancestors is in the universe. The creator is the universe.
beyond the boundaries of the observable universe will be rendered impossible, and any contact between the objects will be lost. The Earth, the Solar System, the Milky Way, and our supercluster will be mutually observable, whereas the rest of the universe will recede in the distance. There may be hypothetical worlds beyond the regions observable to us. They originate as a result of phase transitions of physical vacuum. Alternatively, there may be objects forming out of irregularities of relic radiation located closest to the particle horizon. The question of multiverse objects remains a bone of contention among scientists, prompting an overwhelming number of pseudo-scientific guesses. Be it as it may, most researchers see eye to eye as to the infinity of our universe, although they interpret it in different ways. Some of them claim our world to be multidimensional, which makes our three-dimensional universe merely one of its layers. Others are inclined to believe in the theory of a multi-universe, with us as a minuscule fraction of an infinite multitude, whereas there may be a portal to other worlds beyond the observable area of the universe. Some space theories involve the existence of the so-called event horizon. According to this concept, we're never going to be able to look beyond the event horizon, because the speed at which photons travel away from us will be higher than the speed with which the observable universe expands. According to this theory, all the galaxies surrounding us are bound to recede beyond the event horizon. It will look like time stopped in them. We will observe them infinitely receding beyond the observable boundaries, but never quite disappearing from view. Be it as it may, contemporary science cannot provide a definite answer to this question, although the situation may change overnight once we have developed more advanced observation equipment. The universe might turn out to be a sort of sphere, and traveling over it might remind one of traveling on the spherical surface of our Earth. Considering the scale it reaches, however, this prospect appears impossible. In order to reach the edge of the observable universe, it would take man 46 billion years, even if we travel at the speed of light. By the time we reached this designated point, it would have moved the same distance away, and a similar journey would have to be embarked upon. It is likely that there aren't any large objects beyond the observable universe, and on peering there, we would see just a homogeneous cloud of helium, hydrogen, and a few other elements. However, we might probably never be able to discover the origins of our world, and might forever remain in the position of someone chasing the horizon. July 1967. A series of pulses was detected with the help of a radio telescope at Cambridge University by a postgraduate Jocelyn Bell. They emanate
This is my favorite part, the pulsar. I don't know how they knew, but this is my part. The pulsar. The pulsar. You know what that means, ladies.
Designated LGM-1, which stood for Little Green Men. The name was given following the assumption that these
Green for
perfectly
love.
regular pulses were not a natural phenomenon, but signals of artificial origin, supposedly transmitted by an alien civilization. Besides, the team of scientists under Jocelyn Bell discovered 3 other sources of similar signals. The phenomenon took 7 years to investigate, and the thesis advisor of Jocelyn Bell's team was later awarded the Nobel Prize for studying this celestial body, which was subsequently dubbed BSR B 1919 plus 21. This pulsar was the first registered phenomenon of its kind. Its source was to be discovered several years later in the constellation Vulpecula.
There is absolutely nothing.
Vulpecula, or Little Fox, 2,283 light-years.
The geological history of the Earth bears the traces of many global climate changes, variations in temperature, radiation level.
Wait a minute. See, they trying to get funny on me with this YouTube. Uh-oh. Messed me up.
The first discovered source of this signal was the object dubbed Pt.943. It was spotted by Soviet astronomers in the Leo constellation. One of the most widespread assumptions at the time regarding this discovery was that all pulsars were in fact ultra-powerful radio beacons of extraterrestrial civilizations, and the pulsating signals remind one of a lighthouse twinkling in the night. However, it wasn't long before astronomers agreed that the regular signals were most likely emanated by neutron stars. Today, it is posited that these impulses originate as a result of a neutron star's spinning, and are in fact thin beams of radio waves. They are detected by the observer at precise regular intervals, which accounts for the past appearance of this emission. Approximately 1,790 pulsars had been discovered by 2008. All of them were powerful sources of impulse radio emissions in space. As for the pulsars closest to us, they are located several dozen light-years away from the Sun. After pulsars were first detected, other pulsating sources of similar nature were registered by astronomers. They were described as powerful flares of regular intermittent X-ray emissions. Thus they got their name, X-ray pulsars. X-ray pulsars are also highly magnetized neutron stars, but unlike radio pulsars, which use their own rotational energy, X-ray pulsars are powered by accretion disks. An accretion disk is formed from material captured from the companion star, with the latter eventually becoming a white dwarf with all of its resources depleted. Thus, the mass and spin rate of X-ray pulsars gradually build up during the course of their revolution. As for radio pulsars, they on the contrary slow down as time goes by. For example, the average radio pulsar completes one rotation within the period from several seconds to several tenths of a second, with X-ray pulsars completing hundreds of rotations within the same time period. One of celestial bodies of this kind was discovered quite recently, and it is located rather close to our system. The object was dubbed J1023 plus 0038, and its source caught astronomers' eye as recently as at the beginning of the 21st century. However, its path has reached the Earth only in 2017. This was the first ever millisecond optical pulsar to be discovered. In essence, such celestial bodies are neutron stars as well, with a rotation period ranging from 1 to 10 milliseconds. The spin rate of these pulsars is several times that of regular pulsars. They form part of binary systems, and their spin rate increases to incredible speeds as the direct result of the pulsar pulling material from the gaseous disk produced by its companion star of a smaller mass. It should be noted that when a neutron star is in its active accretion phase, we see it as a source of X-rays. When the rate at which it pulls the material drops, bright pulsed radiation can be seen in the radio and gamma spectra. To date, a few more pulsars of this transitional kind are known to science, which fluctuate between the X-ray and radio spectra in a similar manner. However, it was the first ever transitional optical pulsar with a spin rate of this intensity discovered by scientists. The rotation period of J1023 plus 0038 is 1.69 milliseconds, which is 0.00169 of a second. The object itself is 4,500 light-years away from us. The mass of its companion star is 0.2 that of the Sun. It takes the pulsar 4.45 hours to orbit its companion star once. To date, the properties of J1023 plus 0038 have not been investigated in detail, although it is likely to be a not very massive neutron star. Although the object was initially considered to be a radio pulsar, in 2013 scientists noticed that its impulses regularly subsided and it was known to flare up in the X-ray spectrum. According to scientists, this phenomenon may be accounted for by the fact that the pulsar was at the moment in between the phases, which looks like the following. Radio emissions occur when material from the companion star is pulled to the pulsar, but star wind does not allow material to form an accretion disk. That is why the gas cannot heat up much and looks brighter in the radio spectrum. In the second phase, the stream of material from the companion of J1023 plus 0038 gets stronger and forms an accretion disk around the pulsar. The disk is in fact the source of observable X-ray emissions. It wasn't long before
He said it gets stronger. See, the pulsar, the blood pulses through the veins. It gets stronger. It's just like when a man, when his penis get hard, the blood pulses like a pulsar.
was in charge of the studies, the pulsar may have started to flare up in the optical band due to electrons in its magnetosphere when these electrons' speed was close to the speed of light. In the future, astrophysicists plan to conduct additional observations to study processes taking place within this binary system.
Subscribe.
Now to the
Subscribe.
object of the kind located furthest away from us that is known.
Subscribe. Thank you so much. Subscribe.
Celestial body which is also the brightest of all pulsars discovered by now. Spotted in 2017, this pulsar is an ultra-bright X-ray source. Shockingly, it releases as much energy in one rotation period as the Sun produces in 3.5 years. Earlier, astrophysicists believed these ultra-bright X-ray sources to be black holes. However, after the discovery of NGC 5907X1, it became known that they may turn out to be pulsars too. The object is located approximately 50 million light-years away from our Sun. As for its spin rate, it is variable. For example, in 2003, the rotation period of the pulsar was 1.43 seconds, whereas in 2014 it dropped to 1.13 seconds. Just to compare, if our Earth were to be able to change its rotation speed in the same manner, a day on our planet would last just 19 hours. Modern astrophysical models cannot account for the intense luminosity of NGC 5907X1, although scientists believe it to have something to do with a powerful multipolar magnetic field that may be concealed within the pulsar. It will take even more complex studies to find out the reason for the emission of such staggering amounts of energy. Just a few decades ago, the phenomenon of a pulsar was beyond any explanation, and today science is able to differentiate between this phenomenon and any other in space. Our civilization strides forward, which leads us to believe that even this century may reveal a number of other phenomena unheard of in the past. The universe is like a giant canvas with quite a few blank areas. As our knowledge about space builds up, the pattern on the canvas gets altered too. With regularly applied changes, it may soon turn into a fully fledged map of our enormous universe explored by man.
Trappist. One. Trappist.